Let us learn to derive expressions for displacement, velocity, and acceleration of a particle executing S.H.M. For this, you consider a particle P that moves on the circumference of the circle of radius a with uniform angular velocity omega. Let Pn be the perpendicular drawn to the diameter y dash from P. As the particle P moves on the circumference of the circle, N moves along the diameter y dash to and fro about the center O. Let angle POX is equal to theta, where OP is equal to A and ON is equal to Y. From the triangle ONP, sin omega t is equal to ON by OP. Otherwise, we can write ON is equal to OP sin omega t. As ON is equal to Y and OP is equal to A, we can write the above equation ON is equal to OP sin omega t as Y is equal to A sin omega t. This is the equation for displacement of a particle in S.H.M. Let us shift to the equation of velocity. The velocity of a particle in S.H.M is given by the ratio of displacement and time. Thus, V is equal to dy by dt. As we know y is equal to a sin omega t, the same can be taken as d into a sin omega t by dt. Otherwise, a omega cos omega t. Taking omega common here, we can write the same as a omega into root of 1 minus sine square omega t. Otherwise, V is equal to a omega into root of 1 minus y by a whole square, since sin omega t is equal to y by a. Now the final equation becomes V is equal to omega into root of a square minus y square. Let us derive the equation for acceleration now. As the rate of change of velocity gives the acceleration of a particle in S.H.M, we can write acceleration A as dv by dt. As we know, A is equal to dv by dt. This can be written as d into a omega cos omega t by dt, which is in turn equal to minus a omega square sin omega t. Thus we get acceleration is equal to minus omega square y. This becomes the equation for acceleration.